You were born screaming into a room full of strangers. Someone caught you, wiped you off, and placed you on your mother's chest. You felt her heartbeat for the first time from the outside. You learned the smell of milk. You learned the sound of your own name. Repeated 1,000 times before you understood it meant you. You pulled yourself upright on a coffee table and took a step, wobbled, fell, and tried again. You said a word, probably a bad attempt at mama or dada, and watched two adults lose their minds with joy. And you remember none of it. Not the birth, not the first steps, not the first word. Somewhere in your head is a hard stop, a wall, and everything before it is simply gone. Not blurry, not foggy, gone, as if it never happened to you at all. Most people have an easy explanation ready. Babies are dumb. Their brains are basically unformed, half-finished, not yet capable of holding on to anything. You didn't remember your first 3 years for the same reason a brand new phone doesn't have any photos in it. There was nothing there to save. That explanation feels obvious. It also happens to be wrong. Your baby brain wasn't failing to record your life. It was recording. All of it. And something came along afterward and erased the tape. The discovery nobody expected in 1905, Sigmund Freud gave this mystery its first real name, infantile amnesia. He noticed that adults could recall almost nothing from before age 3 or 4, and he assumed it had something to do with repression memories buried because they were too disturbing to keep. Freud was wrong about the mechanism, but he was right that something deliberate seemed to be happening. This wasn't just fading. This was erasure. For most of the 20th century, scientists simply assumed infant brains weren't developed enough to form real memories in the first place. Case closed. Except it wasn't. In the 1980s, a developmental psychologist named Carolyn Rovi Collier ran a deceptively simple experiment at Rutgers University. She took infants some as young as 2 months old and tied a ribbon from their ankle to a mobile hanging above the crib. Babies kick. It's what they do. But these babies quickly noticed something. When they kicked, the mobile moved. They started kicking harder, faster, more deliberately, delighted that they had discovered a way to control something in the world around them. Here's the part that mattered. Rovi Collier brought the same babies back days later, this time without tying the ribbon to anything. And the babies immediately started kicking, expecting the mobile to move. 2-month-olds remembered the trick for a couple of days. 6-month-olds remembered it for weeks. This wasn't a fluke, and it wasn't reflexive muscle memory. These infants had learned a cause and effect relationship, stored it, and retrieved it on command. Which means the story we'd been telling ourselves that babies simply can't remember was already falling apart. So if infants can learn, and infants can recall, why does every single one of those memories vanish by adulthood? The machine that isn't finished yet deep in the center of your brain, tucked beneath the cortex, is a small, curved structure shaped a little like a seahorse. It's called the hippocampus, and it is arguably the single most important piece of hardware you have for building memories. When something happens to you, a conversation, a smell, an argument, a walk on a rainy afternoon, it's the hippocampus that takes that raw experience and stitches it into something you can replay later. It works in close partnership with the prefrontal cortex, tagging experiences, filing them, and building the retrieval pathways that let you pull them back out months or years later. In an adult, this system runs constantly, quietly, in the background, all day, every day. In an infant, it barely exists yet. The wiring between the hippocampus and the surrounding cortex is still under construction well into early childhood. One especially important piece, a region called the dentate gyrus, acts almost like a gateway, a checkpoint that new memories have to pass through to get filed into long-term storage. In infants, that gateway isn't fully built. Some estimates put full maturation somewhere between 2 and 4 years old. So your infant brain absolutely could form short-term memories, as Rovi Collier proved, with a ribbon and a mobile. What it couldn't do was consistently move those memories into long-term storage the way your adult brain does effortlessly, every single day, without you even noticing. That's a real answer. It's also, it turns out, only about half the story, because in 2014, two researchers uncovered something that made the whole picture far stranger. The brain that destroys itself to build itself. Sheena Jocelyn and Paul Franklin, neuroscientists working out of the Hospital for Sick Children in Toronto, had a hypothesis that sounded almost backwards. What if the very process your brain uses to build itself in early life is the same process that erases your earliest memories? Here's the idea. In the first years after birth, your hippocampus is manufacturing brand new neurons at an astonishing rate, a process called neurogenesis. This isn't a malfunction. It's essential. Those new neurons are the raw material your brain uses to wire up the circuits you'll rely on for the rest of your life, the circuits that let you walk, talk, recognize faces, understand language, and eventually remember things properly. But Jocelyn and Franklin suspected there was a hidden cost buried inside that construction project. Every time a new neuron wedges itself into an already existing circuit, it doesn't just add capacity, it disrupts what was already there. It rewires connections that were, in some cases, already holding on to information, including memories. To test the idea, they turned to mice. First, they artificially boosted neurogenesis in adult mice, whose brains had already slowed down their neuron production, the way ours do after early childhood. Sure enough, those adult mice began forgetting things they had previously learned at a noticeably faster rate than normal. Then, they ran it the other direction. They slowed down neurogenesis in infant mice. And those infant mice held on to memories significantly longer than infant mice with typical rapid neuron growth. The study, published in the journal Science, pointed to a genuinely counterintuitive conclusion. Your baby brain wasn't too weak to hold on to memories. It was too busy growing. The explosion of new neurons that built the foundation of who you'd become was, at the very same time, quietly overwriting the memories stored in the circuits it was rebuilding. Picture a construction crew renovating a house while a family is still living inside it. Walls get torn down and rebuilt overnight. Rooms get rearranged. And in the process, whatever was hanging on those old walls, photographs, notes, anything gets lost in the rubble. That's roughly what was happening inside your skull for the first several years of your life. You weren't failing to save your memories. Your brain was tearing down the very walls they were hanging on in order to build something sturdier. But there's still another layer underneath this one, and it might be the strangest piece of the entire puzzle, the missing you to have what psychologists call an autobiographical memory. The kind where you're the main character of a scene you can replay in your mind. You need something that feels so basic you've probably never once questioned it. You need a sense of self. You need to understand, on some fundamental level, that you exist as a distinct person, separate from your mother, separate from the room, separate from everything else happening around you. Without that, there's no you for an experience to happen to. In the late 1990s, developmental psychologists Mark Howe and Mary Courage argued that this missing sense of self was a critical piece of the infantile amnesia puzzle. Before roughly 18 to 24 months of age, infants don't yet recognize themselves as separate individuals in any coherent way. There's a classic test for this, and it's almost comically simple. Researchers dab a small spot of red rouge on a baby's nose without the baby noticing, and then sit them in front of a mirror. Before about 18 months. Babies look at the reflection and treat it like a different child entirely. They might reach toward the mirror, or smile at it, or ignore it, but they don't reach for their own nose. After 18 months, something clicks. The baby sees the red mark, immediately reaches up, and touches their own face. They understand. That's me. That moment of self-recognition tracks almost precisely with the earliest window in which autobiographical memories can start to form. In other words, you can't remember being a baby partly because, in the way that matters for memory, there was no you there yet. not a continuous narrator sitting behind your eyes, packaging your experiences into a story that belonged to somebody. Just raw sensation, floating with nothing to attach itself to. If that's true, it raises an unsettling question. If there was no continuous self holding those early experiences together, and the very brain tissue that stored them was being physically dismantled and rebuilt around you, is the baby in your old photographs actually you? Or is it someone else who happened to live inside the same body, whose mind was disassembled neuron by neuron and reconstructed into the person reading this sentence right now? It's not a trick question. It's just a genuinely strange one, and neuroscience doesn't have a clean answer for it. The missing language there is one more ingredient, and it might be the one that ties everything together. Developmental psychologist Catherine Nelson spent years studying how children transition from having fleeting, wordless impressions to holding on to memories that actually stick. Her conclusion was that language doesn't just describe memory after the fact, it structures it. It builds the container that memory gets poured into. Before you could talk, your experiences existed as raw sensory fragment sounds, textures, flashes of light, waves of emotion, with no framework to organize them into a coherent scene. Once children start acquiring language, and especially once they start having conversations with adults about things that already happened, remember when we went to the park? Remember the dog that licked your hand? Something changes. Their ability to hold on to memories for the long term improves dramatically. Language gives memory a skeleton. Without it, an experience is like water poured onto sand. It's there for a moment, and then it's simply absorbed, gone, with no trace that it ever existed. This isn't just a theory sitting in a journal somewhere, it shows up in real, measurable differences across cultures. Psychologist Chi Wong at Cornell found that the age of a person's earliest memory shifts depending on where and how they were raised. In Western cultures, where parents tend to narrate their children's lives, constantly asking questions, telling stories, building elaborate personal narratives out of ordinary days, people's earliest memories tend to reach back to around age 3.5. Among the Maori of New Zealand, whose oral storytelling traditions place enormous cultural weight on personal and ancestral history, average earliest memories reach back significantly further, sometimes as early as age 2.5. In some East Asian cultures, where early narratives tend to emphasize family and community over individual experience, earliest memories often start later, closer to age 4. Your culture, quite literally, shapes how far back your memory can reach. Not because the neuroscience is different from person to person, but because the scaffolding placed on top of that neuroscience, the stories, the words, the conversations, differs enormously. Everything. All at once, so here's what actually happened during the years of your life you can't access. Your hippocampus wasn't finished being built, and the pathway that moves short-term memories into long-term storage wasn't fully wired yet. Even the memories that did make it partway through that pathway were caught in the crossfire of your own neurogenesis, new neurons flooding in, rewiring circuits, tearing down the very connections that were holding on to your earliest experiences. You had no continuous sense of self yet, no stable you to serve as the main character of a personal story. And you had no language to give your experiences a shape sturdy enough to survive the passage of time. It wasn't one single cause. It was 4 different processes, stacked on top of each other, each one independently capable of wiping out a memory, all operating on you simultaneously during the exact years when your entire personality was taking shape. Every human being who has ever lived has gone through this. Every person you've ever met carries the same black hole where their earliest years should be a birth they can't recall. First steps they'll only ever know from a story their parents told them. A first word that exists only on a video file, narrated by somebody who was actually there to witness it. And the reason isn't that your infant brain was too simple, too weak, or not yet awake. It's the opposite. Your infant brain was doing something far more demanding than simply recording your life. It was building the very architecture that would let you have a life to remember in the first place. It was becoming you. And to become you, it had to tear down, rewire, and rebuild the person who came before one neuron at a time, until there was nothing left of that earlier version except a body, some old photographs, and a handful of stories other people tell you about someone you'll never be able to remember being.